Before we talk about the math and energy balance, which is the main topic that we will lecture in this class. For that, I will talk to you and introduce you about engineering calculation. The basic unit and dimension is very important for engineering calculation. That's why for engineering, you is petrochemical engineering or chemical engineering. When you measure or when you calculation some value, you have to show or report both value and unit. For example, when you show unit of length, it should, for example, is 2 meters. Or unit of mass is maybe 5.35 kilogram, something like this. These are the unit. And also the dimension. The dimension is the property that can be measured, such as length, time, mass, temperature, something like this. And also the dimension is maybe multiplied or dividing by using another dimension such as velocity. Velocity is the division of length by time. Volume is the multiplication of length with 3 times. Something like this is volume, and the density is the mass divided by the volume. This is the example of dimension. The dimension can be the pure dimension or dimension that generated by the multiplying or dividing with other dimension. The unit also can be treated like a algebraic variable. Like you can multiply, you can subtract, you can add, you can divide. Something like this is the same algebraic. For example, like 3 centimeter minus 1 centimeter, it gets 2 centimeter. That's right, 2 centimeter. But if you minus 3 centimeter minus 1 millimeter, this is cannot subtract because it's different unit. You have to check to be the same unit, something like this. And also, if you would like to multiply or division, you can do that. But the result, you have to show both value and unit. Unit is come from the compound or combined unit from the multiplication or division. For example, right, you multiply 3 Newton with 4 meter, you get 12 is the value or number, and you get the new unit is Newton multiply meter, you get the new unit. That's right, new unit. And this is different between the addition or subtraction. The addition or subtraction, the unit should be the same after you operate. That's right, after you operate. But for multiplication and division, the unit will be get a new one. This is for example of multiplication, and this is the example of division. That's like division 5 kilometer divided by 2 hours. The value is 2.5. The unit is kilometer per hour. Let's get the new unit. Thing like this. It's the same unit. That's right. It's the same unit. Now division. That's right. Division. For example, 6 gram divided by 2 gram, you get 3 gram per gram. So it's the same unit. It cancel. You get no unit for this. We call this is dimensionless quantity. We call this a dimensionless quantity, like this. Okay, this for example of unit and dimension. Another term that is very important for the unit and dimension is we call this a conversion of unit or conversion factor. Conversion of unit or conversion factor is the fraction between the unit. For example, it's 1 centimeter divided by 10 millimeter. We call 1 centimeter is equal to 10 millimeter, or 10 millimeter equal to 1 centimeter. We call this the conversion factor. That's the conversion factor. Conversion factor that we will use this to convert the unit. That's like the same unit to another unit. For example, if we would like to convert the unit of mass from milligram to gram, milligram to gram, we have to use the conversion unit. This is a conversion unit or conversion factor. You know, it's 1 gram equal to 1,000 milligram. We use it to convert from milligram to gram. Okay. the quantity is 36 milligram multiplied by 1 gram per 1000 milligram. You get like the number is 36 multiplied by 1, you get 36, and divided by 1000, you get 0.036. How about the unit? That's right. Milligram divided by milligram. Okay, there's no unit. It's cancel. And then you get gram. This is the gram. Right. 0.036 gram. This example show you to convert the acceleration of 1 centimeter per second square to its equivalent in kilometer per year square. We have to use the conversion factor to change from centimeter per second square to kilometer per year square. The first step, we have to change the unit of second, this of time, to year, something like that. Okay. The first step, you change from second to hour. You know, it's 1 hour equal to 3.6 thousand. That's right, 3.6 thousand. Okay, this is the unit of second is square. The value also square. The unit also square. Okay, this the first conversion factor is from second and hour. And then you use the conversion factor hour and day. You know, 24 hours equal to 1 day. You have to square both the value and unit, both the value and unit. And the third conversion factor is 365 days equal to 1 year. Okay, these three conversion factor convert from second to year already. That's right, because the second cancel, hour cancel, day cancel, the final you get year. And the next step, you have to change from centimeter to kilometer. Centimeter to kilometer. Okay, the first conversion factor we use 1 meter equal to 10 power to or equal to 100 centimeter. And the second conversion factor, you know, is 1 kilometer equal to 1000 meter. That's right. Centimeter is the same. You can cancel. Meter, you can cancel. And finally, you get the unit is kilometer per year square. And the value is 9.95 multiplied by 10 power 9 kilometer per year. That's right. This gives you an example how to convert the unit from centimeter per second square to kilometer per year square. Basically, we separate or we classify the system of unit in three parts or three triads. The first is the base unit. The base unit model is the mass, length, time, temperature, electrical current, light intensity. And the second system is the multiple unit. For example, right, is the minute, hour, millisecond, something else, because minute is you can convert from second. However, you can convert from second because they convert from second to minute and minute to hour and then millisecond, something like this. Right. These are defined based on unit of second. Okay. The last system is derived unit. Derived unit is a unit that's obtained from two ways. The first way is by multiplying and dividing base of multiple units. So we use the base of multiple units. For this, sometimes we call this is the compound unit. For example, the unit of area. Unit of area comes from the multiplying of base unit of length. That's right. Length multiplied by length, we get length square. That is, for example, it's like centimeter square. And another example is unit of velocity. Unit of velocity is the compound unit that composed of feet per minute. That's right, feet per minute, or another is kilogram meter per second square. These are example of compound unit. The last system is the equivalent to compound unit. Something like equivalent to compound unit. For example, right, 1 equal to 1 gram centimeter per second square, or 1 pound force equal to 32.174 pound mass feet per second square. This is we call the equivalent of compound unit. Okay, this is like we can conclude that we have three unit system, right? Base unit, multiple unit, and divide unit. Multiple unit and divide unit. And another kind of system of unit we can classify at least three systems that the most common used, like SI unit. I think you know already SI unit is very common used in engineering. SI stands for System International de United, is SI for short. But the most common unit for SI like temperature. Temperature is Kelvin. The length is meter, mass is kilogram, and time is second. This is SI unit. SI unit, for example. And the second system is CGS system. CGS system is almost identical to SI unit, but there are some different. For example, like mass CGS what is in gram, and length CGS is centimeter. I think this CGS is stand for centimeter, gram, second, something like this. And another is also the most common is the American engineering system. American engineering system. The unit for for the length is feet. Mass is pound mass. Time is second. Okay. For the third three unit to compare between SI, CGS, American engineering unit. For SI, length is meter. CGS is centimeter. And American engineering system is feet. It's different for length, meter, centimeter, feet. And for mass, SI unit is kilogram for mass. CGS is gram for mass. And American engineering unit is pound mass. And the last one is time. SI is second. It's the same with CGS is second. But American engineering system is different. It's also the same, second. Okay. SI, CGS, American engineering unit is the same unit of time is second, but different in mass and length. This is the system of unit that we use in engineering, but the most common that we found is SI and American engineering system. You can find in a textbook. Some textbook is American engineering system, some textbook is SI. The most textbook that's wrote by the professor from America should be American engineering unit, SI. And also in this card, I follow by the fellow textbook is more SI unit, and also some example in the American engineering system. Okay, this for example, the base unit for SI and CGS, right? For the length, SI is meter, right? The symbol in M. For CGS is centimeter, the symbol is cm. Mass kilogram is kg, CGS is gram g. It is of mole, that's common used in chemical or petrochemical engineering, like gram mole or gram mole, you say. Time is second, temperature is Kelvin. Electrical current, it should be ampere, that's right. Light intensity should be candela, CD, that's right, ampere, something like this. And also the important thing you have to know the multiple unit preference, like teka, giga, mega, kilo, centi, milli, micro, nano, something like that. I think you know already. It's basic for engineering mathematics and engineering physical. You know already. And another derived unit that I talked to, like the system of unit for previous base unit, multiple unit, and derived unit. This show you the example of derived unit. I find some like volume. Volume is unit is liter. The symbol is L. The equivalent in terms of base unit lies in cubic meter, cubic centimeter, something like this. 1 liter equal to 0.001 cubic meter or equal to 1000 cubic centimeter, like this. Another example is force. SI is Newton, is N, and CGS is dyne. That's right. The equivalent term of base unit is 1 kilogram meter per second square or 1 gram centimeter per second square. Now this gives you an example of the unit like this. Okay, for this example to conversion between the system of unit from American Engineering Institute or American Engineering System to the SI system. For example, please convert 23 pound mass foot per minute square. That's right. What is unit? It's the unit of force. This is the unit of force. That's right. To it equivalent in kilogram centimeter per second square. Okay, this is the 23 pound mass foot per minute square. You have to convert this to kilogram centimeter per second square. We have three base units. That's right. Length, feet, mass, pound mass, and time is minute. You have to change pound mass to kilogram. You have to change feet to centimeter. You have to change minute to second. That's right. Okay, the first we have to change the mass. That's right. We know the conversion factor, right? 1 pound mass equal to 0.435 kilogram. Okay, for this case you can change mass to kilogram. And the second conversion unit is length from centimeter to feet or from feet to centimeter. That's like we know 100 centimeter equal to 3.281 feet. For this, you can change feet to centimeter. The last unit is time. We have to convert minute to second. Right? We know that 1 minute equal to 60 seconds. But this term you have to square because the unit is square. You have to square both value and unit. That's right. Okay. Pound mass you can cancel. Feet you can cancel. Minute you can cancel. And then you get the unit is kilogram centimeter per second square at this value. That's why the same previous example. That's why we change the unit to the equivalent unit. But this system we change the system of unit. That's why we change the American Engineering System to the SI unit. That's right, to SI unit or CGS unit. This is show the force and weight. The unit of force is Newton. As I talked to you already. So the unit is Newton, which equal to 1 kilogram meter per second square, or 1 die equal to 1 gram centimeter per second square. That's right. And the Newton is SI unit. 1 kilogram meter per second square also is Newton SI unit. And die is 1 gram centimeter per second square. This is a CGS unit. That's right, CGS unit. And also, if you would like to convert to American Engineering System, you have used 1 pound force equal to 32.174 pound mass feet per second square. This is the unit of force. That's right, unit of force. Okay, for example, right, we would like to find the force in Newton required to accelerate a mass of 4 kg at a rate of 9 meters per second square. 9 meters per second square. I think from the physics, you know, it the formula that to calculate the force F equal to ma. That's right. M is the mass of the object. A is the acceleration of the object. That's right, acceleration of the object. For this example, we know the mass of the object is 4 kg and the acceleration is 9 meters per second square. Okay, and then you calculate F equal to 4 kg multiplied by acceleration is 9 meters per second square. Right? And then you can convert from kilogram meter per second square to the Newton, because 1 kilogram meter per second square equal to 1 Newton. This is also the conversion factor. That's right, conversion factor, and then the result is 36.0 Newton. That's right. The basic unit for this is the multiple unit, or the right unit is kilogram meter per second, with equivalent to Newton based on 1 kilogram meter per second equal to 1 Newton. That's right. Okay. For another, that's right, you can convert from American engineering system. Assume we would like to accelerate a mass of 4 pound mass at a rate of 9 feet per second square. Okay. F equal to ma. M is 4 pound mass. A is 9 feet per second square. And then you use the conversion factor. Use the conversion factor from mass to pound force. Okay, 32.174 pound mass foot per second square equal to 1 pound force. And then you get this. And also, if you would like to convert between American Engineering Institute or American Engineering System to the SI unit, we have the conversion factor. Conversion factor for the force, that's is GC. We call it GC. We know it's 1 kilogram meter per second square equal to 1 Newton. That's width equal to 32.174 pound mass foot per second square per 1 pound force. Yes, we can use it to convert from pound mass to pound force, or from American Engineering System to SI system. You can use this formula. The next term is weight. Weight is equal to mass multiplied by gravitational. Gravitational or gravitational acceleration is mg. Previously, force equal to mass multiplied by the acceleration of the object, but the weight is the mass multiplied by the gravitational acceleration, it is g. It's got different. Okay. The unit and the value of g, you can find that is equal to approximately 9.81 meter per second square, or the 9.8066 meter per second square in SI unit. In CGS unit, okay, it's equal to 980.66 centimeter per second square. Or in American Engineering System, okay, equal to 32.174 feet per second square. This is the definition of weight and the unit of gravitational acceleration. Okay, for example, we have the density of water is equal to 62.4 pound mass per cubic feet. The question is how much that 2 cubic feet of water weight, okay, at sea level and 45 degree altitude, and 2 in Denver, Colorado, where the altitude is 5,374 feet and the gravitational acceleration is 32.139 feet per second square. The first step, that's how you know the density, but we don't know the mass of water. You have to calculate the mass of water. The mass of water equal to density multiplied the volume of water. For this problem, we know the density of water is 62.4 pound mass per cubic feet, and we know the volume. The volume of water is 2 cubic feet, and then you can calculate mass of water. The mass of water is 124.8 pound mass. Okay, and then you calculate the weight of water. The weight of water equal to mass multiplied by gravitational acceleration. Gravitational acceleration. And this you have to use the conversion factor from pound mass to pound force, like this. Okay. For this, at the C level, we use the computational is 32.174 feet per second. You substitute G to this and then you calculate rate, we get this value. And also at Colorado, right, with altitude, this value, and also the computational acceleration, it dropped. That's right, to 32.139. You get this weight. You get this weight. For this example, we can see that the error occur by assuming the G with different, because the normally the G at the atmosphere, because at the Earth's surface is quite 32.174. 174. Okay. But some value like in the satellite or another planet, it should be different story. It's maybe different value, something like this. Okay. The next topic we will talk about the scientific notation and significant figure and precision. So the scientific notation, for engineering, we have a lot of technique to report the number. For example, right, we have right is 123 million. This is a lot of number. But engineering, you can drop into 1.23 multiplied by 10 power 8 or 0.123 multiplied by 10 power 9. It is easier. That's right. It is easier. And also 0.00028. But engineering notation, you can report as 2.8 multiplied by 10 power minus 5. That's right. 1, 2, 3, 4, 5. Or 0.28 multiplied by 10 power minus 4. That's right. For the engineering notation, is we drop the number. That's right. For this, a lot of number, like a lot of number. And the next is the significant figure. That's right. That's right. The number of significant digits in an answer when you calculation, when you multiply, when you add, when you subtract, when you divide. It's really dependent the number of digits in the given number and discussed in the rule below. Right? The first non-zero digits are always significant. That's right. 1, 2, 3, 4, 5, 6, 7, 8, 9. All of this is significant. That's right. How about zero? If the zero placed between other digits are always significant. For example, right, 4009, because the zero is placed between 4 and 9. Okay, these two zeros are significant. Okay, 1, 2, 3, 4, 4 significant digits for this. But for this example, what zero is in front of not significant. Right. Zero placed before other digits are not significant. For this, zero are placed before other digit. For this case, 0.046 had two significant digits. And the third one, if zero placed after other digit but behind a decimal point are significant. Right. 7.90 had three significant because this zero are placed after other digit but behind a decimal point. For this, it's before the other digit, right? It's not significant. Right. Okay, the last one, zeros at the end of a number are significant only if they are behind a decimal point. That's right. If the zero behind the decimal point and behind the other digit, okay, it is significant. Otherwise, it is important to tell if they are significant. For example, in the number 8,200, is it not clear if the zero are significant or not? That's right. Are significant or not? That's right. It's maybe true or maybe false. To this, we have to write in terms of engineering notation. It's better to understand. For this case, it's s.2 multiplied by 10 over 3. That's right. It's only two digits. This is also 2.3 multiplied by 10 power 3. This is also 2 digits. This can to avoid the confusing some about the decimal, something another significant digit. Okay. This, for example, right, 2,300, you can write in 2.t multiplied by 10 power t. Okay, had only two significant. Like this. For this, because the zero is behind the decimal, but before the decimal, but place behind other digit. Okay, you can count this also. You have to count this also. 2.00. That's right. At 4 decimal. This also 5 significant. This also 4 significant. With 0 is not significant. That's why this only 2. This 4 significant. Something like this. This for example. Okay. Previous you talk about the significant digit. But this slide how to count the number of significant digits based on the calculation. Based on the calculation, we have two rules for multiplication, division, right? Multiplication and division, and addition and subtraction. For multiplication and division, that's right. The significant digit is the answer based on the least number of significant digits. For this case, we have two number 3.57, 4.286. We have three decimal. This for a three significant digit. For significant digit, the answer should be at least, that's right, 3. That's right, is the minimum. You get 15.30102. The answer is 15.3. Only 3 significant digits. That's right. This also true significant digit. 1, 2, 3, 4. Right. 2 multiplied by 4 significant digit divided by 3 significant digit. The minimum is 2. The answer should be 2. Like this. 3.2 multiplied by 10 power 2 or 220. You get 2 significant digit. This for multiplication or division. The rule is the answer should be the least number of significant digits appear in the equation. That's right. And the next is the significant digit for addition and subtraction. The number of decimal place, the answer should be the same as the least number of decimal place. For subtraction and addition, the answer should be the same, the least number of decimal place. Okay, for this example, we have two numbers. The first number, there's no decimal place. The second number is we have two decimal. That's right, two decimal. But the answer should be the same as the least number of decimal. Least number of decimal. Okay, this is 2, this is 0. That's right. Okay, sorry. The first one is 0 decimal. The second one is 2. The answer should be 0 because the minimum. That's right. The minimum. You get this answer. And the next example, right? We have 1.000 plus 0.06, 0.22. For this case, the minimum decimal is 2. That's right. The answer should be 2. The value is 1.256. Oh, the answer should be only 2. That's right. 1.26. Draw up. That's right. This is also the same. It gives you the significant figure. And the last one is the validating result. The validating result, you can back substitution is straightforward after you solve a set of equations and substitute your solution back into the equation and make sure it works. So you can substitute back. So you can check your answer. Okay, and the last one is the order of magnitude. We compare between these 2 or 3 or the value in the same level. Okay, for example, right, like this. This we call is the approximate, like 27.36. It's maybe 20 or 30. That's right. 63,472. Right, you can approximate like 6 multiplied by 10 power t. Or you can approximate by t. This is the order of magnitude based on the magnitude like this. And for this also you can approximate. You can approximate This is approximately is 4 multiplied by 10 power t. This also approximately 5 multiplied by 10 power minus 2. And this is you can approximate by 5 power 10 minus 4, something like that. And then you get 4 multiplied by 10 power 4 minus 2 plus 4, you get this value. And the last example, right? The calculation is 1 over 4.1 t plus 0.074726. If you compare between these two values in terms of order of magnitude, that's right, in terms of order of magnitude, this is 4.1 t multiplied by 10 power 1. That's right, it's power 1. But for this case, it's 4.762 multiplied 10 power minus 2. That's right, power 1 and minus 2. The order of magnitude is very high compared to this. Okay, you can cancel it because it's very small value compared to this value. Okay, you can approximate this 1 over 4, something like this. This is the approximate technique. That's right. Okay, see you for the next lecture.